Significant digits, or significant figures, are crucial in scientific calculations. They help us express position and avoid misleading results. In today's lesson, we will discuss significant digits in details. All non-zero digits are significant. For example, 123 has 3 significant digits. 66 has 2 significant digits. The zeros between non-zero digits are significant. For example, 105 has 3 significant digits. 1005 has 4 significant digits. Zeros before the first non-zero digit are not significant. For example, 0.0032 has 2 significant digits. 0.1 has only 1 significant digit. Trailing zeros after a decimal are significant. For example, 2.300 has 4 significant digits. We learned that the trailing zeros after a decimal are significant. So what about the trailing zeros before a decimal? And the simplest answer is, it depends on the way you express it. Take the number 50,000 as an example. If the number is written as 50000 without a decimal point, the trailing zeros are considered not significant, and only the 5 is significant, so it has only 1 significant digit. However, if the number is written as 5.0 times 10 to the power of 4, the number has 2 significant digits. If the number is expressed as 5.00 times 10 to the power of 4, the number has 3 significant digits, so on and so forth. So always keep in mind that scientific notation is always the safest way. This might seem a bit confusing so far, but it will get better with more practice. So pause the video and try determining the number of significant digits in each of the following numbers. I'll give you the answers after you try. Here's the answer. You might wonder why we need to learn that. That is because when you're doing calculations in science, you need to keep your answer accurate and realistic, avoiding false position. So now let's learn about the rules in adding and subtracting. When you are adding or subtracting, your final answer should be rounded to the same number of decimal places as the measurement with the fewest decimal places. For example, 12.45, so that's 2 decimal places, plus 3.1, that's 1 decimal place, equals 15.55. The final answer should be rounded to 1 decimal place. Therefore, the final answer will be 15.6. Another example, 12.333, 3 decimal places, minus 55.55, so that's 2 decimal places, equals negative 43.217. And again, the final answer should be rounded to 2 decimal places. And therefore, the final answer is negative 43.22. When multiplying or dividing, you have to apply a different rule. Your final answer should have the same number of significant digits as the measurement with the fewest significant digits. For example, 4.56, so that's 3 significant digits, times 1.4, so that's 2 significant digits, equals 6.384. And you should round the number to 2 significant digits, so the final answer would be 6.4. 66.12, so that's 4 significant digits, divided by 0.01, 1 significant digit, equals 6,612. And you should round the number to 1 significant digit. But how can we do that? In this case, the first and only significant digit is 6, and the rest become placeholders, or zeros. So the final answer would be 7,000. Here is the summary of the section. And that's about it. I hope this lesson cleared confusion on significant figures, and I'll see you in the next episode.